Convinced the Domo guys to let me give a quick mini talk after this. So if you guys want to keep talking, you can, or if you guys want to sit in on it, it's on AngularJS ORM architecture I developed. But if you guys wander in and out, that's totally cool. I won't be offended. Anyways, so to introduce myself, my name's Dean Sofer. I go by Pro Loser online. If you guys have seen me, I founded Angular UI. And I haven't been really active lately because I've been working at my company on this architecture. And I really wanted to give a talk on this, but they had so many awesome speakers. I managed to convince them at the last minute, though, like yesterday, to let me come up here. So although it's called, thank you. It's called Angular ORM, for lack of a better title, but it's actually a bunch of different topics on scalable application design and what we've developed at my company. So I'm kind of an asshole. You can check me out on GitHub /ProLoser. And these are the topics I want to cover, such as like people who have to deal with too much scope clutter, developing a relational model system, which is what ORM is for. Organizing your packages so you can actually make your application get hundreds or thousands of files without crippling yourself, hopefully. Live applications connected to the backend from sockets, so multiple parts of your application stay up to date in real time, and event management, so dealing with all that things and ponies. But I probably won't get to everything because it's a lot of stuff, and I'll try and cut it short. So the Angular ORM I developed, I used 4 items. And one thing I want to say is that these are patterns and prototypes. It's not a library. These are ideas to give you something to take home and try and apply to your own solution, but might give you some new thoughts. So I use CoffeeScript UI router, which is the coolest router out there. You only got 2, but if you haven't checked it out, so CoffeeScript, if you know about it, it's an interesting syntax. If some people ask me, should I pick it up? And I tell them, do you want classes in JavaScript? If so, and were you considering picking up CoffeeScript? Then yes. Otherwise, you might not want to bother unless you got a pro on your team already. UI router has got nested views, named views, state transitions, state management, tokens that you can specify regular expression for, and a bunch of other awesome features. My company uses sockets, which are pretty simple, and we use this awesome library called Bacon.js, which is a stream and event management library. And it's to simplify the socket process, because pretty much a socket is just going to be thousands or hundreds of messages coming in, and a lot of people spend a lot of time wiring it in all over the application. Anyways, so quick intro for people who don't know CoffeeScript. I use CoffeeScript in these demos to make it more concise and show you more useful code. If you see in parentheses with an arrow, that's a function. If you see an @ sign, that's the this dot. And I occasionally leave out parentheses around functions, and you don't need curly braces. So that's just it to the intro to CoffeeScript. So let's build an app. First time most people play with Angular, first thing they do is put a button on the page, and then they put a piece of HTML on the page. And the button is usually toggled by some simple scope variable, and the section of the page is opened and closed by some simple scope variable. And after a couple of hours of playing with it, you've got an insane mess of scope variables, which are pretty much states. And after working with it for a month, you might have hundreds of scope variables, or no rhyme or reason, or cross-communication conflicts with your coworkers where somebody uses one variable name and somebody else uses another, and nesting hierarchy causes variables to get redefined, and it's just a nightmare. So the policy behind this ORM architecture is to remove as much code as possible from the controller layer and move it into an object layer. So this is usually what your controller looks like. You have methods on the controller, scope.save. You actually subscribe to events. You distribute and manage collections, like you query data, you update data, you push data back out. But all that code's done in the controller. So this is models on crack. This is CoffeeScript, the class syntax you can see right here. This is just simple CoffeeScript. It just creates a function, messes with its prototypes. But you can wrap it in a factory. You can wrap, obviously, any code in a factory. The reason I used a factory, not a service, is because a factory really doesn't mess with my objects. It just kind of leaves them intact. So I can define my classes, wrap them in factories, and now I have a base object, which is a simple class, and I can create a person object. And the person object extends the base object, but I can use Angular's dependency injection wrapped around my CoffeeScript to inject the different classes I've been defining throughout my app. And then you can also do nifty little tricks with factories. Since this is a class and you need to spin up instances of classes, which we all know is called objects, you can simply create a singleton by spinning up one instance and returning that instead of the class itself at the end of your factory. So I defined an app object that's like the point of entry for the entire ORM, but I'll go into how these objects are related to each other, not just extending each other. So if you do put all this stuff together, like you start managing save methods, collection management, and all this stuff inside your object layer, your controller becomes irrelevant. The only thing I have to do is take this really powerful object layer, maybe the app object or the person object, and throw it on the scope. And then my view does most of the work. So I can do, instead of scope.save, I can do person.save. I can do person.getPets. And one of the things you need to understand is, if I go back to my code, I don't have samples with this. So a person might have pets. These are pet objects, which are properties of the person object. And since they just show up as properties, the view just starts showing these properties down below in the ng repeat. But to populate the properties, you can just do the parent object dot populate. And so I never even have to go into the controller. Everything is done through nice business logic wrapped in objects. So I'll go into this. So what we did was we wired sockets throughout our entire object relational chain. And normally when you deal with sockets, you got to deal with create, read, update, delete for different objects, usually on the back end. The back end's always got objects, even if the front end doesn't. And so now you have to spread out these events for on object created, on dog created, person created, and you have to now manage all these objects in memory in JavaScript. And this could be in your controllers and services and factories. People create these weird services, but they're really not clearly defined. And you have to sometimes, when you send information back, you have to add context. So say I create a new dog, I need to specify what person was the owner, so the person ID. If the person belonged to a family or a household or a project, I have to specify the project ID. So you have to have all this information from many different objects, tie it all together, and send it to the backend. And you were, of course, doing this in the controller, because that's where you were managing all your collections and all this data. If we use a socket stream, or if we use a bacon stream, the stream is just literally an asynchronous callback hook, something like that. It's literally broadcast and emit in Angular, just supercharged. So instead of just doing broadcast and emit, which is an atomic event, it happens pretty much across your entire app, and the only thing I recommend using it for is somebody logged in, somebody logged out, and not much else. Bacon events are, you have the streams, objects, you can pass them around, but you can filter off of them. So you can kind of shave off a bunch of the events that you don't care about, and you can combine events, and you can have multiple people listen to an event on the same stream. And that's not too different from broadcast, but the filtering comes in really helpful. And so I have what I call a downstream and an upstream, or a socket stream and a query stream. Socket stream is pretty much whenever an event comes in from the socket. I told you there's CRUD usually. There's also custom events. And these CRUD events you use to keep your information up to date, like what people you have and what pets you have. So I take this stream and I pipe it through my objects. And I take the query stream and I also pipe it through the objects. And I do that in this syntax. So this is the syntax to create a stream. This is how I get the socket stream to subscribe to socket events. And down below is how I get my query stream, which is used for upward events. I'll go into that in a minute. And how I send socket messages after a query stream event has fired. So here the constructor of my object, and this is pretty much in the base object. That's why I italicized it, which means nothing. Every time you spin up an instance, you pass in the stream that you're currently holding on to. So at the app level, we just have the application-wide stream. But to go into more detail, so I've got a project stream. When I was in the app and I spun up an instance of the project, I passed in the app's downstream and the app's upstream. But In the project level, I filtered out all the events that don't have to do with this project instance. So now I've cut out the number of events the rest of my objects have to deal with exponentially and reduced the number of callbacks I'm firing. The other thing is when I got events firing upwards, these are used for when I'm sending a request to the socket. Normally you'd have a pet, he wants to save a new trick. So he creates this trick payload, he calls the socket service in, and he directly queries. But the problem is he has to figure out information about his parent, which was the dog. Or this was the trick, he's creating a new trick, he wants to get information about the dog, might need information about the person who owns the dog. And this is like a conflict of interest. But we have this upstream, the query stream, so I just push a new stream event, and I say, this is the payload. And the dog object sees the event, so somebody's passing a query all the way up to the top. I'm going to add any information I have about myself, so I'm going to add my ID as the pet ID, and then we go up one more level and we have the person object, and he sees a query coming through. So he decorates his own contextual information, so he has the person ID. And then finally we get to the very top, the app level, and he fires the actual payload off to the socket. But now every single object is only dealing with decorating the payload with what the object knows about, literally that class definition. And we don't have to deal with the entire payload in one place that spans across multiple objects. And so this is kind of a way to like put veins through your object relationships. And you don't have to use CoffeeScript if you don't like CoffeeScript syntax for classes. You don't have to use classes. You can use any form of relational functions. They simply output prototypes if you like a library. You don't have to use streams or sockets. Sockets kind of gave us an ability to make the whole application up to date. When you think of most applications staying up to date, you think of Google Docs, Asana tasks, you think of chat rooms, but it's one document and a list of multiple documents. And in this system, we've got multiple different objects. So I can be on the dashboard and the users are being updated, their details are being updated, the dogs are being updated. So it's really complex application being enriched in real time across the entire app, and we're doing memory management at the same time. Now, so one of the things we do is I've got a project object, and I should have changed this to person. And the person has pets, and we've got simple methods which maintain the pets collection property of the person or project. So when I query for a pet, we're going to simply do a check to see if the collection exists, and this is how we're doing lazy loading. If the collection does not exist, we'll call the full query, and it'll give me the full collection. So now I've got the full collection in memory, and I return the individual pet the guy wanted. But if it is, the collection does exist, if I think my code's broken, if the collection exists and the object exists, we just return that. If the collection exists but the pet doesn't exist, then what I can do is I can create a new pet, and I'm spinning up an instance of that object. So, and I'm passing, again, my stream. And since we're always passing in the stream that this current object owns, it's always filtered to be only events relevant to that point in time. We're cutting out a bunch of the callback work. And then, yeah, down here inside the constructor, we just create a new downstream, which is even further filtered. It has only events that are relevant to this pet. So now we've got, I'm just repeating myself, so I'll move on. Sorry, I had a lot of stuff, and I was trying to make it go quicker and faster. And, so object maintenance. One of the cool things is we've got events coming in from the back end, such as a person's been updated. He renamed himself. And normally you'd have code like, especially in the controller, you'd have an HTTP request, sends the new payload to the server, and then in the then callback, you're updating the data payload. But this is only in that controller. If you wanted it to be updated everywhere, then you're not using scope.data. Maybe you're using your person object or your collections object service.person object. So you're doing, but in here, the objects listen and keep themselves up to date. So the project object will listen specifically for an event from the socket where you have a type property called update, and the event is pertaining to this specific object, and I already know that this stream is filtered by the ID. So I can just update myself. And all my objects, the individual instances, not just the classes, are subscribed to events to keep themselves up to date and to keep their children up to date, if so need be. So if a new pet comes in, this project or person spins up a new instance of the pet that just was created. So somebody else can create a pet, and it instantly shows up on my screen, and I've got a new instance in memory, and my collection's been up to date, and it'll just pop up because I already took my person and threw it on the scope. The new keyword, yeah. So pretty much the class is just a function, and then I'm creating and adding to my collection. So I do new that function, which was the pet object, passing in my downstream from the current object, upstream from the current object, and the payload from the socket that tells me this is what makes up this new object. Emit and broadcast, you're pretty much going to be dealing with broadcasting across the entire app. You're going to be dealing with scope applies. You're going to be dealing with all these things. And you're just going to be firing a bunch of unnecessary code. And you can't filter off of it. It's really just for atomic events that have to do with the view layer. If you notice, none of these events actually touch the view. All I've been doing is updating my objects in memory. And they're really making sockets easier. I don't even recommend people using broadcast or emit or an event stream with a view layer because scope.watch is 100 times more powerful. And I talked to the core team when I was developing this, and they're like, we don't really have a good event system. They concede broadcast and emit is not the best thing to use because of how watchers work. So really, you just want to use broadcast and emit for something that has to do with scope inheritance. But we're not dealing with scope inheritance. We're dealing with object inheritance. So the ORM is actually ties into different parts of the application. It's not just the model layer. It also allowed me to break down the view layer and the controller layer. So if you check out UI router, and the reason why I bring it up is because the UI router lets me break down my application to mirror the object relationships. So a quick intro to UI router. It's got nested views. So you can see here's a simple route definition. They call them states. They don't call them routes because your application can be in different states. You can have a person state with an ID for that person. Then you can say that person is .open or person.editing or person.running, and then you can get out of that state. So here we have a top state with an ID, and this is the URL it makes up. You can, of course, define you can define a resolve, you can define a controller, everything you'd normally be able to define. The syntax is almost identical to normal router. We got a middle state, and it's defined as a child by simply using this dot syntax, so top dot middle. And if you look at the URL, I'm only defining the additional chunk, so middle/middle ID, but the full URL it amounts to is the parent's URL plus the appended URL. So the cool thing is this state doesn't really have to know a whole lot about the states that came before it. Just like my pet object doesn't really have to know about the owner object and decorate it. So I can literally have in the middle a pet state, and I can have above it a person state. And if you look here, we have IDs or state parameters, the equivalent of route parameters, and I can get the route parameters I defined up here. But at the middle level, I can actually get the one that's defined at this level and above it. And on the third point, you don't have to use a dot syntax to specify parent. It's optional. You can alternatively specify the name of another state as the parent property. And here we have further route appending, and we have a nice 3-state long route, which is long URL. And I can actually access all the parameters that were defined before it. So that's nesting of views. It allows you to break 3,500 line controllers down into 200 line controllers, and actually having 200 directives. I bet you most of them are used only once, but only having 30 services means most of your business logic is stored in controllers and directives. And I don't like one-off directives. I prefer to put views together and controller views together because by having a state, it makes a lot more sense to define that this controller plus view is represented by this state key versus this controller and this view is represented by this random tag. And you can do things like transitioning to states, and it makes more sense when you're playing with your controller. So router's got named views too. So I can, if you see here, I have 2 views in one block of HTML. It's usually at the top level. One's unnamed, one is given a nickname of nav. And here we've got my top level, and I don't even specify a view name, and it will just use the unnamed view by default. But then at a lower level, I can use this views key, and I can actually populate both of them. So from a lower level, I can populate the simple unnamed view that's that level down, but I can still mess with a view that's at a higher state. And the cool thing is, if you open a person and you want to show the person's name in the header bar of your application, you might have found yourself having a service that sends that person object to the directive, and you have some directive in the nav, and you've got weird communication going on. But here, all the code is in the same place. It's defined at the state level, and child states will override parent states. So if I go down even further and somebody else can override the nav, or he can append to it. So he can have a nav which includes his parent state data plus his current state data. It's just really powerful. And one feature which I like to think I helped bring in, it was an open pull request when I started playing with the UI router. It was resolve chaining. And a lot of the guys were busy, and Nate Abel here, who you can talk to if you want to learn more about the router, and also Tim Kindberg, who's floating around, long hair, super tall. Also, another guy who's been really active on the router. They helped me get this feature in. And what this does is, normally you deal with resolves, but you deal with an NG router. It's a flat routing system. So because we have this nesting system, we can say top state or top route. We want to resolve something like my app object. That's super simple. You do that everywhere. Then at the middle state, I actually want to use that app object I resolved to do a new resolve. So app.getPerson. And then one more level down, I can say, I want to bring in the person object at this level and get his person.pet property. Because the only way to get objects is through properties of other objects, through the relationships. And the cool thing is, the UI router will actually wait. And it will wait until the top states have been finished resolving before starting to resolve the next ones. And it actually does a check to make sure that you actually need to wait. If your resolves don't require anything from parent states, it'll just skip the wait and start doing them in parallel. Go ahead.
If you're resolving two different sibling states under a parent, given the concept of resolve once and it remains resolved when you ask for it again, if I swap to a sibling, is that one asked for again, or is it use that resolve previously valued?
So you asked if two sibling states resolved. The problem with that question is it's a slight confusion on the understanding of UI router. You can have two views, but you always have one resolve. So if I resolve something, it will be, I can resolve 3 items. They'll be in parallel, if that was what you were asking.
Well, if I have person, person.bob, and person.com, if I'm transitioning from person.bob to Tom, does person resolve again in that transition?
So the person object.
Here, I'm just crashing your part.
Cool. You have to.
The correct answer is no.
Okay.
All right, so no.
Hi.
This is Nate Abel. Abel.
No, nobody pronounced it correctly.
Yes.
Can I just get a quick show of hands? How many people use
This isn't being. You should get a mic so we can actually have it stream. Will this work?
Is that?
You should turn it on.
Are we allowed to?
No.
Oh, hey, thank you. So nice of you. Hi, guys. All right, continue.
So you're just going to fix my mistakes?
Yeah, pretty much.
All right. So
and or heckle you.
Well, there are other features in the router, such as one of the features of this nested system is, say you have 3 state levels down, and only the bottom level is moving around, as you were asking, then no, the levels above it will not be re-executed. They won't be re-resolved. So we're only resolving states that are actually being changed. And you can jump absolutely to the middle or to the top, anywhere you want in the state tree, and only the parts that are changing will be resolved. So the cool thing is, the DoubleClick team complained about, if you have nested controllers, nested scopes, and you might try and come up with a convention and force your coworkers to agree with, okay, every time I open a person or do a person, or we have some sort of service, and the service has a lot of great logic, or this data payload has a lot of the main info everybody needs, you could put it on root scope.currentPerson. And then you have to make sure everybody on all the controllers down the list respect and reuse root scope.currentPerson or just scope.currentPerson. But the problem is that, as they were saying, you start to, you're 4 routes, you're 4 levels deep, and you're making a dependency on something you are not 100% sure, you become even less sure as time goes on, that was actually defined. Maybe root level person just got messed with, or somebody screwed up with it. So the cool thing is, even though I resolved in this demo the person at one state up, I can re-inject him for the controllers in lower states. So say I want to perform synchronous logic in the controller. I just want to perform something with the person object in the controller. I don't have to do scope.person and cross my fingers and hope that that object is populated. I can explicitly demand that as a dependency in my controller signature and say, bring me person. I know somebody above me defined it. And at least you have that sort of contract, because that's what your dependency injection is. It's a contract saying, I need these resources in order for me to function. So say you're getting down too far or you want to execute logic in the controller, you can just reset that scope dependency.
Man, you just don't ever stop talking.
No, I don't. Thank you. You're just going to be the guy who forwards me along. Yeah, I have a tendency to repeat myself. So one other thing we did that this is, I don't think is in the normal router. It's on enter and on exit. I'm not sure how many people use this, but it's a little event that's fired. And the cool thing is, in our application, say I've got a person, he may get hundreds more events than simply CRUD, simply keeping himself up to date. These might be special, unique events that the person can do. And when I'm not looking at the person, I don't want to be performing a lot of logic or even checks on this person when he's hidden in the background. I only want to do it to the guy I currently have on the screen, on the view layer. So I created a simple base object method called open, which subscribes all the special custom events. And I have baseObject.close, which unsubscribes all these events. And the state manager, this isn't even in my controller. This is just defining a state. Will open the object, subscribe all the events, and then when I leave this state, I don't even have to put it on the enter of another state. It's literally this route, this state definition, keeps track of its own responsibilities.
By the way, guys, if you have any questions about any of this, feel free to shout them out and interrupt them.
Yeah. And so now my state definitions aren't bleeding together. You get the point. So that way we're killing memory consumption. We're killing overhead of our application. In addition to filtering off the events that weren't even related to the model, we're now filtering off the events that aren't really going to visually affect our application. That's pretty much it. I was going to do a whole section on how I distribute this file breakdown, this application structure through module relationships. And then Tim Kindberg was like, actually, we fixed this one feature in the router, so you don't have to do that anymore, which was you couldn't declare states out of order. You had to declare them in order. That's apparently no longer an issue.
Yeah, states are now wired up like just in time. When you move from configure to runtime. So yeah, you can define parent and child states out of order.
So one thing I will say, since I've got a few of you here, this was part of the discussion, the initial points. Don't break your application down like this with directives and models. That doesn't help you. It doesn't make sense. If you take out the models module, your whole application falls on its face. You want to break it down by responsibility. Few people have said this here and there. It's not pushed out into the community well enough to be widely adopted. I wanted to dig into how, if you think about it, I can take my pet object, I can have it depend on my core base object. I can also take the pet routes and put those inside of the pet module, and it doesn't have to know about what modules came before it because it just appended. So I can package all these things together, and using UI router, I can even package routes into this module, and I can rip out this module and plug it in on somebody else's application. Or I can have an edit module, which can be plugged in and attached to the user module or the animal module. And this may not be perfectly working yet, but I think I might push them towards that direction. But the point is, you can now reuse this edit code and just make all the route paths, all the route definitions agnostic or position relative. Path relative versus path absolute.
There are ways to take like a set of states and like attach them to another set of states, but you have to define them as objects, and there's not like we don't have a real like friendly API for that right now or anything. So, but that is something that's on the radar.
Yeah, and that's pretty much it. The reason why I wasn't going to go into this is because this is what my logic amounts to. Which is, if somebody's like, that, I don't understand that. I'm like, I probably shouldn't go into it then. But you want to distribute your dependencies across your app. And anyways, that's my presentation. Thank you.